All right, so now that we have all that groundwork done, let's go ahead and practice what we're doing. So notice, and I'm using both notations, right? The IJ notation and the less than, greater than notation. And so in each one of these, right, the first thing we're going to do is sketch what this given vector looks like. So that's pretty easy. We just basically go back to what we've been doing for a long time, right? Our initial side or our starting points at the origin, we're going 3 units in the x direction, 4 units in the y direction. And so there would basically be the vector 3, 4, right? Over here, right, we're going 1 unit in the negative direction, 2 units in the y direction. So there would be my vector -1, 2. Here, there's my x direction and my y direction. So if I'm drawing a picture, right, I'm going 3 units in the negative x direction and 1 unit in the negative y direction. So there would be that vector. And then last but not least, for this one, right, there's my x component and my y component. We're going 2 in the x direction, and 1, 2, 3, 4, 5 in the y direction. So essentially what I've done is I've given us a vector in every single quadrant, right? So there's the sketch of each vector. To find the magnitude, remember the magnitude of my vector, whatever it is basically my x coordinate, right, plus my b coordinate squared, square root. It's essentially your Pythagorean theorem, something that we've been used to for a while. So the magnitude of this vector, right, is basically the square root of 3 squared plus 4 squared, which is 9 plus 16, square root of 25, so we get is 5. Right, so there's the magnitude. The magnitude of this vector, right, is my -1 squared plus 2 squared, which basically comes down to the square root of 5. Okay, so there's the magnitude of, that's the length of that vector. Over here, the magnitude of v is -3 squared plus -1 squared. I believe that becomes the square root of 10. So that's essentially the length, right, of that vector there. And then last but not least, the magnitude of this vector, right, is 2 squared plus -5 squared, right? That becomes, I think, the square root of 29. So that's how long that vector is there. So there's basically your magnitude. It's essentially your Pythagorean theorem. The direction angle, recall from my definition, satisfies the fact that the tangent of that angle is whatever my b component is over my a component. So theta is basically the inverse tangent, right, of the b over a. And then here's where things get interesting, right? Because remember, when we use this, right, tangent, the inverse tangent only gives us an angle between -pi/2 and pi/2. So we're gonna have to be really careful, or -90 degrees to 90 degrees, right? So we'll be careful. So for starters, right, over here, right, how about I just cut to the chase? The tangent, the inverse tangent of my b component, which is 4, over my y component. Using my calculator, I'm going to tell you guys I'm kind of new to all this explain everything stuff, so I don't know how to work in the calculator in here. Just trust me, I am over off to the side here I'm actually using Desmos, right, to find what is the tangent for an inverse tangent, excuse me, of 4/3. And what I'm getting is 53, and we like 4 decimals, right? 0.1301 degrees, right? So there would be my angle theta right there. So 53.1301 degrees. Again, over here, my theta is the inverse tangent of my y coordinate over my x coordinate. So in this case, essentially just -2. So plugging that into my Desmos here, right, what I'm getting is -63.4349. Okay, but we want to go in a positive rotation here. So basically using this becomes our reference angle right there. So the theta of direction I'm looking for is 180, right, minus that 63.4 349. So that's where it gets a little interesting. So when I do that, what I end up getting is, oops, 116.5651 degrees. So that's what that angle is there, right? So 116.5651 degrees. So now I've got my angle theta, and then just on and on, right? So for this one, theta is the inverse tangent of my y-coordinate, which is -1, over my x-coordinate, which is -3. So it's essentially 1/3, right? And so when I do my work here, right, what I end up getting, again, I'm going to just punch this into my Desmos. Sorry for the pause, just punching numbers here. What I get is theta equals 18.4349. Now we got to be careful because that's this angle there. We need to rotate all the way around. So basically the theta of direction I need, right, is 180, right, plus what we just found, 18.4349. So when I add 180 to it, right, what I'm getting is 198.4349. All right, so that angle right there is 198.4349. All right, and then last but not least, right, my angle theta over here, right, is the inverse tangent of my x-coordinate, or excuse me, my y-coordinate, -5 over my x-coordinate. So when I put it in my calculator, right, what I end up getting for this one, -5 divided by 2, we get -68.1986 degrees. All right, but of course what that is that reference angle right there. So we need to actually go all the way around to find our theta that we want. So in this case, right, how about we take 360 and subtract the 68, 119.86. All right, so 360, right, and then and so what I'm getting there is 291.8014. All right, so that's the angle of direction there. So 291.8014 degrees. All right, so there are all my direction angles. And then lastly, we can put this all together, right? We can rewrite this as a scalar multiple. That's basically your magnitude times your unit vector, which is the cosine sine theta. All right, so let me do a couple of these, right? So for this one, let me just borrow the notation I'm using there, right? This vector, we call it V for the moment, is the magnitude, which we found to be 5, times the unit vector, the cosine of 53.1301 degrees, times the sine of 53.1301 degrees. Right, and so there would basically be that. Of course, we can do it in IJs, but I'm going to go ahead and leave it at that. The rest, right, just to kind of cut the video a little short, are all the same, but let me go ahead and do an IJK one. So for this one down here, right, my magnitude we found to be the square root of 10, right? So this would be the, I don't know where to put this guy, right? So it would be the square root of 10 times the cosine of 198.4349 degrees, right? That's in the I direction, plus the square root of 10, the sine of 198.4349 degrees, and that's all acting in the J direction. All right, so that's, again, we're using what we've, by definition, right, any vector, let me draw it up here, is its magnitude, right, basically times its unit vector. And so we found theta give me the direction, right? Cosine of theta gives us how much is acting in the x direction, how much is acting in the y direction, and then the magnitude gives us the size. So I did it a couple times, but you can just mimic what we did for the next two, right? Magnitude times the cosine and sine of that angle, right? Magnitude times the sine and cosine of that angle. I think you guys get the point, and I'm already 10 minutes into this, and I have more examples to do. All right, so let me pause there for a moment, all right, and I'll see you in another video coming soon. But there's your practice of our vector component and our vector forms.